We are the very shrewd life in the known universe. I mean, envision that we're the key spot where there is data in this unlimited structure. Cosmologists all around the world are in wonder of this continually evolving openness. The James Webb Space Telescope has captured the unnoticeable glow of city lights an astounding 7 trillion miles from Earth, defying all expectations. This stunning accomplishment achieves more than just broaden our perspectives regarding what we know about the universe. Hypotheses run wild as experts pore over the data, seeking signs that could unlock the mysteries of these baffling, phenomenal markers. The concepts are astonishing, confirming that we are following in the footsteps of a few rare beings in the universe, that the universe is overflowing with life and development incredibly far beyond our understanding. Is it conceivable that these distant lights show the presence of extraterrestrial societies? What does this mean for our understanding of the probability of life in the universe beyond Earth? Join us as we examine how the James Webb Telescope just saw city lights 7 trillion miles away. Launched into space on Christmas Day 2021, the James Webb Space Telescope was designed to surpass the highly regarded Hubble telescope in capturing remarkably sharp images of newly discovered bright objects, planetary systems, and more. A primary objective of the JWST is to focus on the formation of the earliest galaxies by investigating the distant neighboring regions of the universe. This is possible because the travel time of light throughout our universe spans billions of years. When the JWST gathers light, it captures these objects precisely as they were billions of years ago. Space experts measure distances in light years, which is the distance light can travel in 1 year. To demonstrate this, the mission's first major achievement was a vast field image that was presented on July 11, 2022, by U.S. President Joseph Biden while speaking from the White House. While the Hubble Space Telescope focused on a single region of the sky for 10 consecutive days beginning on December 18, 1995, the Hubble Deep Field captured a small spot making up around 1/1,000,000th of the entire sky. The majority of the 3,000 currently indistinct objects found by Hubble were massive galaxies located billions of light-years away. Focusing on the SMACS 0723 galaxy cluster, the JWST Deep Field covers a similarly small sky region. The galaxy cluster SMACS 0723 is 4.6 billion light-years away, and the more distant galaxies behind it are magnified by the cluster's extraordinary gravitational field. The light of these magnificent galaxies is bent into large arcs where the gravitational field is most intense. In one case, it was confirmed that it took a distant galaxy's light 13 to 14.1 billion years to reach the telescope. Due to the expansion of the universe, the emitted light stretches as it travels through space. The primary goal of the JWST has been to capture visible light from stars in the infrared. Astronomers can clearly distinguish between JWST and visible light photographs of neighboring galaxies taken by Hubble and other telescopes. By gathering data at these frequencies, we can observe how galaxies have evolved over immense time scales and merged into the shapes we see today. Even more remarkable than the sheer number of structures in the JWST's first deep field image is how quickly it was captured, in mere hours compared to days or even weeks for other telescopes. Everywhere it looks, JWST can't resist discovering galaxies. Galaxy clusters aren't the only objects acting as enhancing lenses. Experts used the JWST to capture an image of a pair of galaxies designated VV1191 to study how the light from one galaxy of the pair changed as it passed through the other. The consequences of this study will reveal the properties of the interceding cosmic systems. Furthermore, it appears that the JWST may have actually made an excellent revelation: light from a very far-off galaxy. The assertion of the possible presence of auroras on an exoplanet came from the official JWST site. The lack of a host star and the frigid temperature make it hard to pinpoint where the energy in the upper atmosphere is coming from. In any case, the fact that the object showing aurora is indeed producing methane is significant. Just like auroras on Earth are caused when charged particles from the Sun are captured by our planet's magnetic field, these charged particles then move through Earth's atmosphere near the poles, where they collide with gas particles, creating a brilliant light show called the aurora borealis. Jupiter and Saturn have similar auroral phenomena because of the solar wind. However, the astonishing W1935 has no star to orbit, so its auroras are a major mystery. Attention continues to focus on Proxima Centauri and TRAPPIST-1, around 4.4 light-years from Earth within the Milky Way. Researchers have detected the presence of water on the exoplanet, and the possibility of life there cannot be ruled out. Are we finally going to see evidence of life beyond Earth? Just last month, the JWST observed another incredibly massive black hole. This enormous black hole was seen in various wavelengths and is consuming everything around it. This discovery is 40 million times the mass of the Sun. But what does this mean for us? The JWST has found that this extremely massive black hole has been present since the beginning of the universe and likely isn't moving. This giant is rapidly consuming everything in its nearby region. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Ben-Gurion University of the Negev in Israel. According to their findings, the supermassive black hole is nearly 40 million times heavier than the Sun, making it a colossal entity. Fortunately, it is located at a vast distance from Earth, around 12.9 billion light-years away. Still, it is drawing closer, with the black hole consuming everything around it at a fast rate, as indicated by the redshift. When the JWST started sending back its privileged data, researchers were thrilled as they sifted through the information. In the uncovered program, 3 small objects with a faint red glow caught their attention. They initially thought it was a nearby massive black hole. However, when they investigated the data, utilizing gravitational lensing, scientists have found something considerably more fascinating. The revelation of similar peculiarities in other early universe supermassive black holes has provided new insights into the evolution of both the black hole and its host universe, as well as the connection between the two. This is still largely mysterious, but it could give evidence of the early-stage development of massive objects like star-forming materials that fell into black holes. Space experts cannot yet fully understand what's happening in the images returned to Earth, but one thing is clear. The James Webb Space Telescope is constantly discovering new, unusual objects. Every day, we have the joy of exploring space and being enchanted by the stunning lights of planets and stars that float across the universe light-years away. Not only does the JWST allow us to see far beyond what our eyes can grasp, but it has also revealed a mysterious object in one image. This picture, which focused on something else, was taken by the European Space Agency, observing 2 young stars forming around 1.47 light-years from Earth. However, there is a small orange mark at the bottom of the image that resembles a question mark. Remarkably, this small shape is far from insignificant. In fact, it's massive. The question mark shape was captured while observing the arrangements of young stars known as Herbig-Haro objects, which are surrounded by large rings of gas and dust. Regarding the question mark shape itself, it might appear this way from its specific perspective due to the two-dimensional nature of the image presented by Webb. As of now, we have no idea what it is, and without further study, we may never know. However, the discovery has been confirmed by experts, and it's likely a distant structure or possibly galaxies interacting with each other. The question mark shape could result from their combined gravitational interactions. Given the influx of distant, exaggerated structures revealed by Webb, there is a continuous surge of new, unexpected questions. All eyes are now focused on a particular arrangement of Earth-sized planets that could hold the key to finding extraterrestrial life. This ongoing question, which includes the need for evidence of advanced extraterrestrial life in the universe, could ultimately be settled despite the high likelihood that such beings exist. Where are these planets? They lie precisely 40 light-years from Earth in the nearby star system known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to find habitable planets, NASA is considering a wide range of criteria. Beyond a planet's size and distance from its star, a more comprehensive approach is to assess the overall conditions of the planet's atmosphere, as this would allow researchers to determine if the planet is habitable. The Infrared Spitzer Space Telescope, part of NASA's space exploration mission, revealed the 7 rugged exoplanets orbiting the same star, TRAPPIST-1, several years ago. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. JWST has consistently made groundbreaking discoveries since its launch, and this finding is the latest in a series of record-breaking firsts. This is the first detection of light emitted by an exoplanet as small and cool as those in our own solar system. No other telescopes have had the capability to measure such faint mid-infrared light. Space experts were thrilled when they first learned about the 7 TRAPPIST-1 exoplanets, as these distant worlds are all Earth-sized and located within the habitable zone, the region where planets can have liquid water on their surfaces. However, the TRAPPIST-1 planets are currently beyond our reach, situated a staggering 235 trillion miles away. They orbit a much smaller and redder star than our Sun, known as an M-dwarf star. These stars are far more common in the Milky Way than Sun-like stars and are ideal targets for planet hunters. However, M-dwarfs are also more prone to flaring and emitting high-energy radiation, which could harm any emerging extraterrestrial life or a planet's atmosphere. When we turn our attention to TRAPPIST-1b, we find that it is tidally locked to its star. One side of the planet is constantly facing the star while the other remains in perpetual darkness. This temperature difference creates extreme conditions, with the daytime side reaching temperatures hot enough to melt iron. The dark side stays much cooler, though still warm enough to prevent the formation of methane, a key atmospheric gas. Although this may reduce the planet's potential for hosting life, JWST's ability to measure these extreme conditions offers a unique perspective on distant exoplanets and their environments.